Some old hippie came a-hopping through our apartment. Did you hear me? Some old hippie came a-hopping through our apartment. If you want to know what that means, follow me in this lesson. Many students struggle with trigonometry, particularly understanding the sine, cosine, and tangent functions. These functions are the building blocks of trigonometry, but they can be daunting at first. This now explains my creative use of the SOHCAHTOA acronym when I said, some old hippie came a-hopping through our apartment. As we go through this lesson, you will see how this fits into the context of our trigonomic ratios. So, let's dive into the lesson. Trigonometry is the branch of mathematics that deals with the relationship between the sides and angles of triangles. We can use trigonometry to calculate unknown sides and angles in right-angled and non-right-angled triangles. Now, whenever you're going to be dealing with triangles at all, when you're approaching questions concerning any triangle, it's always important to start with this particular question. Is it a right-angled triangle? Now, if your answer to this question is yes, there are only two possibilities that you should be thinking of. The first possibility, it could be Pythagoras' theorem that you're asked to use. Now, the Pythagoras theorem states that a squared plus b squared is equal to c squared. Now, a and b are the two shortest sides, while c is the longest side. Second option, it could be SOHCAHTOA. And we're going to be looking in this lesson in depth as to what SOHCAHTOA is all about. So, question, how do you know which one to use? Very important question there. Now, if you know two sides of your right angle triangle, then you are talking about Pythagoras theorem. However, if you know one angle and one side, you are going to be using SOHCAHTOA. So, let's proceed. Now, before we navigate any questions concerning right-angled triangles, it's very important for us to review the four parts of a right-angled triangle. So, as you can see here, I have put that in, that a right-angled triangle has four parts. So, first part we're going to look at is the angle. Now, I've put a symbol there which is called theta. Now, theta is a Greek symbol for an unknown angle. Now, also, theta could be either of the acute angle. So my first angle here is acute. We know an acute angle is always measuring less than 90 degrees and greater than 0. Now, it could also have been this angle at the top here. Either of these could be an angle on the triangle that we're given. Now, we then go ahead to look at the longest side of the triangle. Now, the longest side of the triangle is called the hypotenuse. The hypotenuse is always opposite to the right angle. Now, why this is important is because our diagrams are not always drawn to scale. So if it's not drawn to scale, we're not able to clearly see which side is the longest side. However, I know it's always opposite to the right angle, and that's how I identify it. Now, third part rather, opposite to the angle is always the opposite side. So the opposite side, I'll reiterate that, is always opposite to the angle, which we have called theta. So I hope you're thinking, if the angle in question is this acute angle here, it means that the opposite side would have been along here. So it depends on where your angle is. you will be locating your opposite side. But remember, it's always facing the angle that you're working with. And the final part is our adjacent side. So the adjacent side here is next to theta, or rather it's the part of the triangle, the side on which the angle sits. So those are the four parts of the triangle. I would say at this point it's a very good thing for you to draw this triangle out, pause the video, draw the triangle, label the parts, because this is critical to what we're about to get into. Okay, so moving along. Now, as it relates to trigonometric ratios, there are three basic trig ratios. The first ratio is sine. The second ratio is cosine. And the third ratio is the tangent ratio. Now, what is sine? Now, remember we talked about that trigonometry looks into the relationship among sides and angles in a triangle. So as we talk about the sine ratio, sine is the opposite side of the triangle divided by the hypotenuse. Cosine, on the other hand, is the ratio of the adjacent side of the triangle divided by the hypotenuse. And for the tangent ratio, it is the opposite side of the triangle divided by the adjacent side. Very, very important. But as usual, I have little tricks here that can help you to remember how to find these ratios. So no need to worry, how am I going to remember that? Remember, in my introduction, I did say that some old hippie came a-hopping through our apartment. Okay, so that's a very, very good way to remember our ratios. As you can see here, I have put sine. So S is for sine, and O is for the opposite side, and H for the hypotenuse. So the sine ratio, the sine of an angle, will always be equal to the opposite side divided by the hypotenuse. And also, concising this into a triangle also helps to navigate in terms of, should I multiply when I'm given this question, or am I dividing? Now, if you look here, if I want the opposite side of a triangle, all I need to do is to multiply my sine, the sine of my angle, multiplied by my hypotenuse. However, if I want to find the angle, I need to do the opposite side divided. So this bar here acts as a division sign. So opposite divided by hypotenuse gives me my angle, and the opposite divided by the angle will give me the hypotenuse. Many of us know how to use these triangles already because we've used them in things like finding speed, distance, and time, and so we know how to manipulate these triangles. So another beautiful way to concise information that helps us to remember it. Now, as it comes to the cosine ratio, the cos of an angle is equal to the adjacent side divided by the hypotenuse. And another triangle there to concise that information. And the tangent ratio, we're talking about the tan of an angle will always be equal to the opposite side divided by the adjacent side. So, in school we normally say, so katoa, so katoa. So, sometimes when students say to me, so, I say katoa. Now, when they've not started doing this topic, they're wondering, what is she talking about? But you know, I love to talk about the language, so it helps for us to remember what we are taught. So, another way to look at it, some old hippie came a-hopping through our apartment, and all the letters I have highlighted here are still pointing to our ratios. So, katoa. So is for sine, ka is for cosine, and toa is for the tangent ratio. Now, with that beautiful foundation being laid, we are now ready to look at what does this look like in a particular question, and how do I know which one of these ratios I need to use. Okay, now before we get into the question, very, very important here to know how to manipulate our calculator. So I've put a beautiful calculator on screen here. I want to make a very important note at this point. Do not borrow a calculator from anyone on the morning of your exam. Always make sure the calculator you use in your lesson, it's the same calculator you're taking to your exam. Remember, calculators are different and they function differently as well. So just a little interjection here. I remember telling my students this: do not borrow a calculator. Someone came to the exam, they didn't have their calculator. Now, invigilators are not allowed to tell you how to operate your calculator. That is simply a breach of your exam. So someone put their hand up when I was invigilating and they've asked, "Miss, do you know where is pi?" And I said, "I ate it." Hope you got that joke right there. Of course, because I am not allowed to say where it is on the calculator. So make sure you ask your teacher in your lessons how to navigate your particular calculator. So if you've got this Casio calculator as I have on screen here, your trigonometric ratios are right here where this arrow is pointing. You can see here sine, cos, and tan. Now usually in Key Stage 3, when you're in year 7 and 8, you do not use these functions. So you're wondering all along, what are these buttons for? They are for calculating sides and angles of triangles. Okay, now with that being said, make sure that at this point you're looking on your calculator. If you hadn't brought your calculator to this lesson, you need to pause the video, run and get it, because all of this that we're doing now, you will need your calculator. Okay, now it's time for us to see what does this look like in a question. And all of these questions are exam style questions. So I've put the ratios on screen here, and this is just because we are just being introduced to the topic. So I like to have little tips that will help you as you navigate your way. So we're asked here in this question to find the value of x. Now, also paying attention to the degree of accuracy. We're asked particularly to give our answers to 2 decimal places. Now, examiner's tip. If it is that you have gotten the question right, but you did not pay attention to the degree of accuracy, automatically you have lost your answer mark. And remember, we talked about in previous videos that 1 mark is the difference between your grade boundaries. So by now you catch my teaching style. I always love to give clear logical steps. So I'm given this particular triangle and I'm asked to find the side x. Remember, you must ask the question, is this a right angle triangle? And the answer is yes. Now, 2 possibilities just to remind you. We're either doing Pythagoras, but I did say at the beginning we will not focus on Pythagoras here, but I'm still keen on focus on your logical thoughts as you approach a question. So I can see here I do not have 2 sides that I know, so clearly Pythagoras would have been ruled out. Okay, now I have an angle and I have a side that I know. Straight away, I know I'm going to be doing SOHCAHTOA. So, focus, step 1. So step 1, I must label the sides of my triangle. Now, very important note here. Whenever we are going to label the sides of our triangle, our reference point is always the angle. I cannot stress that enough. I must stand at my angle, and from there I will now focus on the sides that I have got. So I've got an angle of 62 degrees. Now from facing 62 degrees is the opposite side. We've established that at the very beginning. Now, opposite to our right angle is our hypotenuse. So I'm just going to label H. Now, do not label the side that has no letters or numbers. This will cause confusion. Only label the side you know and the side you are trying to find. Now, once we have labeled the sides, I can see here that I've got the opposite side and the hypotenuse. I look back on my ratios now and I ask myself, which ratio has O and H? That brings us to step 2. I need to choose my ratio. So the ratio that has both O and H, I can see here is the one in orange, which is the sine ratio. So I'm going to put a tick here. I have labeled my sides. See, logical sequences. I have now chosen my ratio. I know I am using the sine ratio. So I write that down. I go along to my third step. I now need to write my formula out. Now, a good practice when you are learning a new content is to always write your formula for every single question and then substitute into that formula. The reason you're doing that is to embed that formula. Remember, we discussed not all formulae are given on exam papers. You will get some of them, but clearly you're not getting all of them. So it's very important that you know them as well. So we're going to now write our formula out. So I'm going to write that sine theta is equal to the opposite side divided by the hypotenuse. So I'm ticking that off. I've now written my formula out, and then I go for my fourth and final step, which is to substitute the values from the question into the formula and then finally calculate. So let's go. I've got sine theta. I'm looking back on my diagram, and remember, theta represents the angle. So the angle here is 62 degrees. So I'm just going to write sine 62 degrees is equal to my opposite side, which was labeled x here, and my hypotenuse was labeled 7. Brilliant. I have now substituted. Finally, I now need to calculate. So I'm just going to put this over 1 here just to give my denominator for this fraction. Now I can see here, if I multiply 1 times x, that gives me x. So to find what x is, I simply need to do sine 62. I'm going to put my 62 in bracket. It is very important to put that 62 in bracket. If you do not put that 62 in bracket and then you put multiplied by 7, your calculator is going to think you are finding the sine of 62 sine 7 rather than the sine of 62 and that answer multiplied by 7. So now we're going to go ahead and we are now going to put this in our calculator. Now, I want you to look for patterns here as well, because what if in this question our letter is on the numerator, but I want you to pay attention and look for pattern. What if your variable is in your denominator? So we go ahead and we put in our calculator sine 62. We make sure to close our bracket. So sine 62, we close our bracket. Then we put multiplied by 7. So for the purpose of this question and to reiterate a very important concept I've identified among students, I'm going to put my answer first of all to 3 decimal places. And then I will pay attention to the degree of accuracy. The question asked me which was 2 decimal places. So the answer is 6.1806. I'll just put 4 DPs there, and then my final answer, because I was asked to round to 2 decimal places, I will count 1, 2 places after the decimal, then I will check the one after those 2 positions. Remember, if we have 4 or below, we round down. And if we have 5 and above 5, we round up. Now, please note as well, rounding down does not mean dropping off the numbers. It simply means write the number as it is without adding or subtracting anything. So here, final answer is 6.18 centimeters is my unit. And there we go. We have completed our first question as we build our skills on using trigonometry to find unknown sides and angles. So I'm dealing with sides first, and then after that we're going to be dealing with angles. So that's my first example on finding an unknown side. Well done. So we're going to be moving on to our second example. So here, I'm asked to find the value of x in this question, also to give my answer to 2 decimal places. So I focus on my steps. Step 1, I know I must label my sides. And my reference point is standing at the angle. So I'm going to go and I'm going to stand at 49 degrees here. Opposite to 49 is 26, which is my opposite side, so I'm going to label that O. Facing my right angle is the hypotenuse, which is the longest side. I'm just going to go ahead and label that H. Now that I've labeled it, I can see here I'm focused on the opposite and the hypotenuse. Question: which ratio has O and H? So I need to choose my ratio. And I can see here, again, it's the sine ratio. But is the context of the question changing here? We will see. So I'm going to tick off, I've labeled my side. I have now chosen my ratio because I know I am doing sine. So third step, I need to write my formula down. So let's go. So sine theta is equal to my opposite side over my hypotenuse. Then I go for step 4, substitute and calculate. So let's go. Sine, the angle given here is 49, so sine 49 degrees is equal to, I can see this time my opposite side is the number, so 26 divided by x. See, I told you, sometimes your variable is in your numerator and sometimes it's in the denominator. So I reason, if when my variable was in the numerator, I multiplied. Clearly, if my variable is in the denominator, I'm not going to divide. So, easy way to navigate this is then to say that x then would be equal to 26 divided by sine 49. And there we have it. We'll put that in our calculator. Okay, so I'm going to do 26, put that first, then divided by sine 49. Close my bracket, press equal. I'm going to write my answer first of all to 3 decimal places, and then I'm going to round it to the degree of accuracy the question has asked me to do. Notice at this point, I go back, check my degree of accuracy, underline that to give myself a focus. So I'm going to write 34.450. I can see here 4, 5 are the 2 decimal places and 0 is the third, which means that I have nothing to add on. So my final answer then, x has to be 34.45 and my unit is centimeters. Amazing. Well done for making it into your second example. And I can just sense, I can feel that clarity coming through to you. And that is absolutely fantastic. So far we have dealt with the sine ratio. And we've looked at when our variable is in the numerator, and the second example when our variable was in our denominator. So we move on to a third example. Here we are asked to find the value of x and also give our answer to 2 decimal places. Yes, we check it's a right angle triangle, therefore we know it's going to be Pythagoras or trig, but we know it's going to be SOHCAHTOA because we're dealing with angle and sides. Step 1, we label our sides. Again, reference point standing at the angle. I notice here I do not have an opposite side. Therefore, I must be using the adjacent and the hypotenuse. Put in the one that's easiest first. So I know the longest side is facing the right angle. That's the hypotenuse. So that's h. And if I didn't have the opposite, the other side has to be the adjacent side on which the angle sits. So I've labeled my side. I go on to now choose my ratio. I ask myself the question, which ratio has A and H? I look at them, I can see A and H is the cosine ratio, so that's cos. So I'm going to write it beside here. I've chosen my ratio and it's the cosine ratio this time around. So I go ahead and I look for my formula. So I'm going to write that cos theta is equal to the adjacent divided by the hypotenuse. Tick that off. I've chosen my formula. Now it's time for me to go to step 4, where I'm going to substitute and calculate. So I look on my diagram. I know that the angle here is 34. So cos 34 is equal to the adjacent side is 12 and my hypotenuse is x. So from previous example, I can see here that my variable is in my denominator. Hence, I know straight away I will need to divide. So I'm going to do that x will be equal to 12 divided by cos 34. I go ahead and I put that in my calculator. So putting that in my calculator, I get my answer to be 14, so I'm just going to write that here, 14.474. However, I was asked to do 2 decimal places. So again, I check. 1, 2, check. 4 is to be rounded down. So the final answer is that x is equal to 14.47 centimeters. Absolutely fantastic. You can see here that once you've mastered the step-by-step approach here, it really doesn't matter which one of the ratios you have. The concept remains the same. Awesome. So now we're going to do another example. Here we go. So I'm asked here to find the value of x and give my answer again to 2 decimal places. So at this point, our pace begins to change. We begin to go a little bit faster because now we are getting into the momentum. We understand what we're doing. And remember, in exams, pace is very important. It is a very good practice when you're working independently at home to time yourself on questions. If you're in an examination and that question is taking you more than 3 minutes maximum, you must leave that question and move on to other questions. What you don't want is for you to spend time on a question that's seemingly very problematic and ending up not finishing the paper when there were questions that you would have done fluently and scored those marks. Leave the question, come back to it at the end. Very good tip there. So, step 1, we need to label our sides. So we go to 34, our reference point. Again here, I notice I do not have an opposite side. So I go ahead, look opposite to my right angle is the hypotenuse, label h. Therefore, I'm trying to find the adjacent. Tick that off, I've labeled. Next step, I need to choose my ratio. Again, I have A and H. Clearly, I can see here, I am using the cos ratio. I'm going to write that down, tick that off, give myself that thought. I now need to write my formula down. So cos theta is equal to adjacent divided by the hypotenuse. And then I need to substitute and calculate. Can you see? We're moving a little bit faster now because it is becoming repetitious, and so we are a little bit more fluent in what we're doing. So I'm going to substitute. I've got cos. My angle in the question is 37 degrees and the adjacent side is x. Awesome. And the hypotenuse is 13. Very important where we put them. Now I can see again my variable is my numerator. Clearly I will need to multiply for this question. So again, to see that clearly, I can put my denominator here as 1 cross multiply. 1 times x gives me x. Then I need to do cos 37, which I must put in bracket, multiplied by 13. I put that into my calculator. And I will write my answer, 3 dp's, and then focus on my degree of accuracy. I've got 10.382, and I check. I realize my 2 is below 5, so I've got to round down. So therefore, x is equal to 10.38 centimeters. And there we have it. We have now completed 4 questions. If I was a student, this is what I would have done. I would have made a note that whenever my variable is my numerator, I need to multiply. However, when my variable is my denominator, I need to divide. Okay, now having said that, let's go ahead and look at another example. So in this question, we're asked to find the value of x and also to give our answer to 2 decimal places. So we know by now, step 1, we need to label our sides. So I go to my reference point here, and I can see that x is my opposite side. I can see that I do not have any relationship here in this question, any business at all dealing with my hypotenuse. So therefore, I have my adjacent side. So I'm going to tick that off. I have completed my first step, labeling my sides. Now I need to choose my ratio. So which ratio has OA? And that is tan. So I am going to just write tan here and then tick that off. So now I need to write my formula down. So tan theta is equal to the opposite divided by the adjacent side. I can see here on my diagram that I am going to need to substitute my angle for 52 and my adjacent side for 4. And of course, it's very important to note the order of O and A matters. So I now need to substitute and calculate. So tan 52 is equal to my opposite side, which is x, divided by my adjacent, which is 4. Question: am I multiplying or am I dividing? I hope that you've said multiplying, and that's because my variable is in my numerator. Again, I can just put this over 1 for clarity and then do 1 times x, which is x, and that lets me know I need to multiply tan 52, put that in bracket, multiplied by 4. I go ahead and just put that in my calculator. So tan 52 multiplied by 4, I'm going to write that as well to 3 decimal places. So that's equal to 5.119. I go back, pay attention to my degree of accuracy, which is 2 decimal places. Therefore, I'm going to say that x now has to be equal to 1, 2, check. I need to round up because I've got 9 is my 3rd decimal place. So the final answer then is 5.12 and centimeters. Brilliant. So we've now looked at some questions on the sine ratio, the cos ratio, and now we have done one question on the tangent ratio. I am absolutely proud of you. You are doing fantastic. Okay, so let's go ahead and look at another question. Now in this question, I'm asked to find x also to 2 decimal places. Go ahead. Step 1, label. Reference point angle. So I've got my opposite side here, and I have my adjacent side. Only those two I will label. I check that off. I'm going to choose my ratio. I have OA, TOA. So that's the tan ratio. Tick that off, chosen my ratio. Now I need to go for step 3. I need to write my formula. So tan theta is equal to my opposite divided by the adjacent side. Chosen my formula, check that off. Now I need to substitute and calculate. So the given angle here is 34. So tan 34 degrees is equal to my opposite side is 11 divided by my adjacent side, which is x. I can see here my denominator is a variable. Therefore, I need to, you've said it right, divide. So x then is equal to 11 divided by tan 34 degrees. I put that in my calculator, and the answer for that, notice I always use arrows, no equal sign, because I cannot have two equal signs in one sum. So then I need to do, I've got 16.308. Question asked me for 2 decimal places. So I check 1, 2, check. Number behind is 5 or more. It's greater than 5, so I need to round up. So x then is equal to 16.31 centimeters. Absolutely brilliant. Now I just want to take the time here just to point something out. Before approaching any question with linear components, it is very important to check whether all the units are the same. For example, on this shape, I cannot have a centimeter and a meter. I would then have to convert one of them so that I have unified them. Always check before navigating. Now the reason I hadn't done that is because here in these particular questions we only have one side, and when we have one side, no need to do that. But you will see what I have just said and how important that is when we get a little bit further. So we're going to now move along. So you can see here that most of all that we have done rather, are finding the unknown sides of the triangle. And we did say at the beginning, we could also be asked to find unknown angles. So off we go. Now we are asked here, what we're going to focus on is calculating unknown angles. Now you will recognize that because you have now done calculating unknown side, principles remain the same. However, we're just going to be doing some inverse operations. So on we go. So before we get on, just want to do a quick reminder of the parts of our right angle triangle. We know we have theta, the unknown angle, a Greek symbol used to represent that. Then we need to know that it could be either of the angles that are acute that we're referring to. We looked at our hypotenuse, which is the longest side. Diagrams are not always drawn to scale, so the easiest way to find this is opposite to the right angle. We also looked at our opposite side, which is always opposite to the angle given. And then we've looked at the adjacent side, the side on which the angle sits. Awesome. Now, with that in mind, let us look at inverse operations. So we know inverse speaks of opposite. So simple ones. The inverse of multiplication is division. The inverse of addition is subtraction. The inverse of squaring is a square root. So then, what is the inverse of sine, cos, and tan? I bet you didn't know that they also have inverse. Well done. So this is where we are now going to focus on our calculator again. Very important here. So we're going to have a look on our calculator. Now the inverse of sine is sine inverse theta, written with a -1 as a power. The inverse of cos is cos inverse theta. And the inverse of tan theta is tan inverse theta. Again, pause the video, write this down. And then we're going to look at what does that look like, especially when it comes to manipulating our calculator. So focus, calculator. I put my calculator back here. Now, what should I press? This is what I'm asking myself. What should I press on my calculator to get the inverse of any one of these trigonometric functions? So, steps. Now, to get the inverse of sine, cos, and tan, you simply need to press shift. Now, I have put here also, some calculators do not have the word shift. Rather, they have second function. You'll see that as 2nd second. It means the same thing. And this brings back what I've said earlier. Always make sure you know your calculator inside out. So, if your calculator doesn't have shift, look for second, which is second function. Once we press our second function, we then will press either sine, cos, or tan. And what that does is bring up that inverse function, which I'd write here. So sine inverse 1. That's what it looks like if you are in the right mode. And now a thought that has also come to my mind here is that whenever you are going to navigate questions involving degrees, you make sure your calculator is on degrees. Your calculator could also have been on radians, or it could have been on gradient. Now, how do I know my calculator is on degrees? On your calculator face here, there should be a small d. Now, if your calculator is not on degrees, you are not going to get the correct answer. One thing about calculators, they will produce an answer, or they will simply say syntax error. But in order to make sure you are accurate, make sure you check first of all, it's always on degrees. Okay, so now we are going to find an unknown angle. Not difficult at all. So we are asked to find the value of x to 2 decimal places. This time we recognize we do not know the angle, and x is the angle. Concept remains the same. So then I go for my first step. I need to label the sides. Reference point, the angle. So I go to my angle. I notice here now I know 2 sides, very important. So I know I'm going to need inverse function if I know 2 sides of a right angle triangle and asked to find the unknown angle. The only time I'm using my inverse functions. So from x I can see 11 here is the opposite side, and the longest side is my hypotenuse. So for this question, I am clearly using the sine ratio OH. So chosen my ratio, I am using sine. Tick that off. I now need to write my formula. So sine theta is equal to the opposite side divided by the hypotenuse. Now in this particular question, theta is given to be x. So I'm going to rewriting this, I'm going to substitute at the same time. So sine x, x is what I'm asked to find, is equal to the opposite side, which is 11, divided by the hypotenuse, which is 13. Now I can see I have a fraction. Now, similarly to solving a linear equation where I do the inverse of my operations, the same principle apply. Remember, we've discussed that the inverse of multiplication is division. Now the inverse of sine is sine minus 1. So x then would be equal to, I'm going to do the inverse of sine, so it's sine inverse, and in bracket I'll put 11 divided by 13. Now I will put that on my calculator. So what I'm going to do now, I'm going to press shift or second function to bring up the sine inverse, and then I'm going to do 11 divided by 13. So sine inverse 11 13, x then would be equal to 57.795. I absolutely love this question, and I love to take opportunities. This is a beautiful opportunity to revise for students who never get their rounding right once they have a situation where the number they're rounding up to is already 9. The same principle of the column method addition or subtraction applies here. I can see asked to do 2 decimal places. However, when I check, I can see that I'm going to be needing to round up, but I'm going to need to add 1 to 9. Now this 9 will now becomes 10, and I put 1 in the other place here. So this now becomes 57.80. So therefore, that is the final value for x, and I put my degrees here because I am working out an angle. Now you can see here that the basic concept is the same. The only thing that has changed here is that we are doing the inverse function. Everything else remains the same. Okay, so now that we've done that example and you've experienced finding an angle, what I would do as a student at this point, I would have just paused the video when I see the other question comes up and challenge myself. Am I able to do this by myself? This is checking your application skills. Okay, so we're moving to another example. Step 1, I need to label. So I go to my angle, and I recognize I do not have my opposite side. My hypotenuse faces my right angle. Orientation doesn't matter. And also I have my adjacent side. So I have labeled. I am now going to choose my ratio. I've got A and H. So I know I'm working on cos. So let's write that down. Cos, check that off. I now need to write my formula, and then substitute and calculate. So let's write our formula. So cos theta is equal to the adjacent divided by the hypotenuse. I'm going to replace my theta with x. So cos x, because I don't know what it is. And then the adjacent side is 3, and the hypotenuse is 5. So I've checked that off. I've substituted. Now I need to calculate. Now I'm finding an unknown angle. What am I thinking? Inverse function. So then I know x will be equal to cos inverse of 3/5. I then put that in my calculator. So cos inverse of 3/5, I'm going to write my answer to 3 dp's, which is 53.130. I need 2 decimal places. So 1, 2, other number is 0. So the answer is 53.13 and degrees. Okay, well done. So we've now completed 2 questions. And I think you have guessed this. We've done sine, we've done cos. So I feel like you know we are going to explore the tan of an angle. Brilliant. Okay, final question here as it relates to finding the unknown angle. And then I've put some question in for you to pause the video, have a go, and then I'll display the answers. So step 1, we are going to label. Reference point is x. We have been given our opposite side here. I can see nothing has been given for my longest side, so hypotenuse completely ruled out. The other side has to be the adjacent. So tick that off. I now need to do step 2, ratio, or a toa. So that's the tan ratio. Check that off. Next step, I need to write my formula. So tan theta is equal to the opposite over the adjacent side. Check that off. Next step, substitute, calculate. Feel the rhythm? I feel it. So tan x, I don't know the angle, so tan x is equal to the opposite side, which is 8, divided by the adjacent, which is 7. I now need to do the inverse. So x then would be equal to tan inverse of 8/7. Close your bracket, you enter that into your calculator. So tan inverse of 8/7, 3 dp's, that gets me to 48 48.814, but I need to round to 2 dps, so x then has to be 48.81 degrees. Round of applause. You have gotten a long way. Of course, I'm proud of you. Brilliant. Now, with all of that being navigated there, it's your time to shine. So I've prepared these 3 questions for you. I have given you the ratios, and I've also given you the steps to follow, but I haven't given you a hint as to which one to use where. Now, it's your time. Pause the video, have a go at these questions. My confidence in you is 150%. So I knew you got these right. So let's have a look at our answers. So for the first one, you should have used TOA, the tan ratio. And your answer should be 29.05 degrees to 2 decimal places. For the second question, you should have used the sine ratio, which is 39.52 for your answer. And for the final one, should have been the cos ratio, which is 27.27 degrees to 2 decimal places. Well done for getting those correct. Key takeaways, we know we always come to that. We always come to our key takeaways. I always say in a lesson, you're thinking. You ask yourself as you go in, what am I expected to learn today? And at the end, you ask yourself, have I achieved what I came for? If your answer is no, you have some work to do. So, key takeaways here. Remember, whenever we are dealing with triangles, we always start with, is it a right angle triangle? That brings my thought into 2 locations. Either I'm doing Pythagorean theorem or I'm doing SOHCAHTOA. How do I know if I'm using SOHCAHTOA? I'm using SOHCAHTOA if I know an angle and a side. I'm using Pythagorean theorem if I know 2 sides of this right angle triangle. Next point, we are always making sure we know the parts of a right angle triangle. There are 4 parts. So we talk about theta, which is the unknown angle. We talked about the opposite side. We talk about the adjacent side and the hypotenuse. Okay, you should have also taken your notes on those so you can always go back and look, and remember, orientation doesn't matter. We also looked that there were 3 basic trigonometric ratios. 1 is sine, 2 cosine, and 3 the tangent ratio. And then finally, my last word to you for this lesson. If you have found this content useful, go ahead and support the channel by subscribing. Also, make sure that you hit the notification bell. Share, let's continue to build our community. And another very important part here is that check us out on TikTok. Yes, we are now on TikTok, where we're doing additional exam style questions, different from the ones we have done in the lesson, which you will find quite beneficial. Thank you so much for watching.